Hello to all, welcome to the channel Money's Gate Tech Vision. In the previous presentation, I explained some basic operations of matrices and determinants. In this lecture, I will tell you about types of matrices from linear algebra in engineering mathematics. Let me go to the lecture. Normally, the types of matrices can be classified by two categories. First one on the basis of appearance of elements in the matrix. We know matrix is an array of elements which are arranged in rows and columns. Based on the appearance of elements in the matrix, these types of matrices can be classified. And second classification on the basis of properties of matrices and determinants. On the basis of appearance of elements in the matrix, that can be subclassified on the basis of number of rows and columns, based on the structure of matrix elements, and based on the values of matrix elements, it can be subclassified. Types of matrices can be subclassified. And on the basis of properties of matrices, on the basis of properties of determinants, the types of matrices can be subclassified. So I will explain one by one. First, on the basis of appearance of elements, first category on the basis of appearance of elements in the matrix. So type of matrix, this is the nature of elements, this is definition. On the basis of number of rows and columns, it can be classified into two, row matrix and column matrix. Row matrix is the matrix in which only one row is there. Only one row. That one row has two or more elements up to n elements. Here I have represented X as the matrix which consists of only one row which has the row elements x1, x2 up to xn. Two or more elements in the row, only one row will be there for the row matrix. And for the column matrix, only one column is there. Two or more elements can be in one column. X equal to x1, x2, x3 up to xn are represented here. And second, on the basis, second subclassification on the basis of structure of the matrix elements. On the basis of structure of the matrix elements, it can be classified. First type is square matrix. So let me take this example. This is a 3 cross 3 matrix. Consists of 9 elements. We know about the square shape. Square shape is a shape has equal sides. So here also we can find out that in the left side 3 elements are there. In the down side 3 elements are there. Here in the right side 3 elements are there. And in the up side also 3 elements are there. 4 sides are equal. So these elements are structured like a square. So it is named as square shape, a square matrix. Equal number of rows and columns are there. This is the definition for the square matrix. And let me take second type, rectangular matrix. So we know about the rectangle shape. Rectangle is a shape which has equal opposite sides. That is, opposite sides are equal. Here, for example, I have taken 2 cross 3 matrix. 2 cross 3 matrix. So here 2 cross 3 matrix means 2 rows and 3 columns. This is a matrix consists of 2 rows. This is the first row, this is the second row, and 3 columns. First column, second column, third column. So here opposite sides are equal. So here the downside 3 elements are there, upside 3 elements are there, left side 2 elements are there, and right side 2 elements are there. Hence it is named as rectangular matrix. Otherwise it can be defined as it is a matrix which has unequal number of rows and columns. And third type of matrix is diagonal matrix. We know square and rectangle has diagonal. Diagonal matrix is a square matrix in which diagonal elements are there. Other than the diagonal elements, other elements are 0. Okay. So here the diagonal elements are 1, 3 and 5. 1, 3 and 5 are the diagonal elements. Other than the diagonal elements, other numerical values are 0. All non-diagonal elements are 0 in the diagonal matrix. So this is the definition for diagonal matrix. And scalar matrix. Next type is scalar matrix. Scalar matrix is a diagonal matrix, but in which the diagonal elements are equal in value. Diagonal elements are equal in value. So here 3, 3, 3, they are equal. Equal diagonal elements. All diagonal elements are equal. That is a scalar matrix. And unit or identity matrix. So it is also a diagonal matrix in which all the diagonal elements are unity. So that is a representation for unit or identity matrix. And then A triangular matrix can be classified subclassified into upper triangular matrix and lower triangular matrix. Upper triangular matrix is the representation like, so this is the upper triangle elements. So how it can be defined? We have to find out the principal diagonal elements. So here diagonal elements are 1, 3 and 5. This is the upper triangle above the diagonal elements, and this is the lower triangle below the diagonal elements. So upper triangular matrix is a matrix in which uh, in which the elements above the diagonal will be there. So elements below the diagonal are 0. Above the diagonal elements, there will be the element values will be there. That is the upper triangular matrix. And lower triangular matrices is a matrix in which lower triangular elements are there. That is below the principal diagonal. Here principal diagonal elements are 1, 2 and 5. So this is a lower triangle below the principal diagonal elements. So lower triangle has the elements. Upper triangular has only 0 values. So it can be defined as elements above the diagonal or 0. Lower triangular is a matrix in which elements are there in the below triangle, in the lower triangle, below the diagonal elements. In the lower triangle, there will be elements below the principal diagonal. Okay, this is the representation for lower triangular matrix. And third subclassification on the basis of values of elements. So already we have classified on the basis of rows and columns and on the basis of structures of elements, and here on the basis of values of elements, numerical values of elements, it can be classified into symmetric matrix and skew symmetric matrix. First, I will tell you about symmetric matrix. Here I have taken one example. It is a 3 cross 3 matrix. It consists of 9 elements. Here we have to consider the diagonal elements only. Below the diagonal element, lower triangle. Above the diagonal element, upper triangle. See the upper triangle and lower triangle. Here also 4, 5, 6. Here also 4, 5, 6. So the diagonal elements above the diagonal elements and below the diagonal elements are equal in value. So hence we can find out the matrix which is symmetric or unsymmetric. Okay. Otherwise, it can be defined as in a square matrix A equal to A transpose. I will tell you here. A equal to A transpose. We know transpose of a matrix is the matrix in which row. This is the second column 4, 2, 6. And this is the second row 4, 2, 6. Again, second column and second row are equal. And third column and third row are equal. 5, 6, 3. And here also 5, 6, 3. So third column and third row are equal. So thus it can be represented as, this matrix can be represented as A equal to A transpose. This is the condition for the symmetric matrix. We can find by the triangle also, or we can find by the A equal to A transpose condition. So it can be otherwise represented as Aij equal to Aji. Aij element will be equal to Aji element. For example, this 4, the position is A21, and here in this 4 A21 equal to A12, and here A31 equal to A13. Like that we can find out the matrix which is symmetric or skew symmetric, like that. And here next classification is skew symmetric matrix. Skew symmetric matrix is a matrix in which the lower triangle and upper triangle are equal in value, but it is the negative of the values. Upper triangular values or lower triangular values, it is a negative of the other values. So otherwise it can be defined as, here 4, 5, 6 are there, same values only, but negative of those values. Okay. And then principal diagonal, see the principal diagonal elements. These diagonal elements are 0 for the skew symmetric matrix. This is the other condition for skew symmetric matrix. We have to see the upper triangle and the lower triangle also. Thus we can represent A equal to minus A transpose. So here 0, 4, 5, and here first, it is the first column 0, 4, 5 are the elements. First row 0, minus 4, minus 5. We can write the condition as A equal to minus A transpose. It is otherwise defined as Aij equal to minus Ji. Other condition is all diagonal elements should be 0 for skew symmetric matrix. So for skew symmetric matrix, two conditions are there. One is negative of those values, other one is principal diagonal element should be 0. So previously we have seen on the basis of numerical values, and this one is on the basis of complex values of elements. Hermitian matrix. Hermitian matrix is a matrix in which here also we have to consider the diagonal elements upper triangle and lower triangle. See the upper triangle and lower triangle. Upper triangle is represented in green color and lower triangle is represented in red color. These are the complex values. Okay, so here 4 plus I, 5 plus I, 6 minus I. Here 4 minus I, 5 minus I, 6 plus I. 4 minus I is the conjugate of 4 plus I, 5 minus I is the conjugate of 5 plus I, and 6 plus I is the conjugate of 6 minus I. So hence we can define the condition in a square matrix A equal to A bar. A bar is the representation of matrix, complex conjugate of matrix. Okay, A bar whole transpose. Okay, or it can be otherwise represented as A naught. Aij equal to Aji bar. That means conjugate of Aij. Here, this element is the conjugate of this element, and this element is the conjugate of this element, and this element is the conjugate of this element. So here A21 is the conjugate of A12, and A31 is the conjugate of A13. Like that, here A32 is the conjugate of A23. So thus we can define the condition for the Hermitian matrix. Okay, upper triangular will be the upper triangular elements. Upper triangular elements will be the conjugate of lower triangular elements. So thus we can find the matrix whether it is Hermitian or not. And like the skew symmetric, here also we can define skew Hermitian matrix. So here I have taken one example, same example I have taken. Like the skew symmetric, here also negative of those values. So negative of the lower triangular values will be the upper triangular values. Okay. And also the other condition is principal diagonal element should be 0 for the skew Hermitian matrix, like the skew symmetric matrix. So here 4 plus I, 4 minus I is the conjugate. Negative of the conjugate of the elements. Negative of conjugate of the elements. Okay. So here it can be defined as A equal to minus A bar whole transpose. Minus of A bar whole transpose. Okay. Transpose of the conjugate of the matrix A. Minus A naught. Otherwise it is represented as minus A naught. Here all diagonal elements are either zeros or purely imaginary. Either it can be 0 or here I have represented 0 only, or it can be purely imaginary. Purely imaginary means only imaginary part will be there, real part is not there. For example, we can take 2i, 6i and 7i like that. Only imaginary part should be there in the principal diagonal elements. Principal diagonal elements. Instead of 0, it can be purely imaginary for skew Hermitian matrix, for the type of skew Hermitian matrix. And then unitary matrix. Unitary matrix, it is a square matrix when A naught A equal to I. The product of A naught A equal to I. I is a unity matrix. Okay. I is the unit matrix. This is the condition for the unit matrix. And then second classification, second category on the basis of matrices and determinants. Thus I explained on the basis of values of elements and structure of elements like that. Here on the basis of matrices and determinants. And then first one on the basis of properties of determinants. Matrix can be classified as singular matrix and non-singular matrix. Singular matrix is a matrix in which the determinant delta equal to 0. If A is a square matrix means determinant of A should be equal to 0. That is a type called singular matrix. And non-singular matrix in which the determinant value is not equal to 0. Determinant value not equal to 0. And then on the basis of properties of matrices is a special type of matrices, orthogonal matrix. I will tell you the condition for the orthogonal matrix. If A is a square matrix, product of A transpose, that should be equal to A transpose into A, that should be equal to unit matrix. The final value should be the unit matrix. We know unit matrix is the matrix in which the diagonal elements are unity. So the product of A transpose equal to the product of A transpose into A, that should be equal to identity matrix. It is the condition for orthogonal matrix. And invertible matrix. Invertible matrix is the condition for the invertible matrix is A should be a square matrix. A inverse should be equal to A inverse A. That should be equal to unit matrix. This is the condition for invertible matrix. Another one important point is that an invertible square matrix is orthogonal if the condition is, if this condition is satisfied. If A transpose is equal to A inverse. If this condition is satisfied for the invertible square matrix, then that matrix is said to be orthogonal also. Then on the basis of third classification is idempotent matrix. Idempotent matrix. The condition for the idempotent matrix is A square should be equal to the original matrix. A square should be equal to original matrix value. And nilpotent matrix. Here if A is a matrix, then A power n equal to 0, where n is the least positive integer. The value will be equal to 0 for nilpotent matrix. And involuntary matrix. This is a matrix, then this is a matrix when A square equal to I. I is the identity matrix. Square of the original matrix should be equal to identity matrix. That is an involuntary matrix. Every unit matrix is a idempotent matrix and involuntary matrix. For every unit matrix, this idempotent matrix condition is satisfied and the involuntary matrix condition is satisfied. So hence we defined the types of matrices on the basis of appearance of elements and on the basis of properties of determinants and matrices. This is the channel. Name is Mani's Gate Tech Vision. This is the channel for GATE aspirants. You can subscribe to my channel, share and share to your friends also. Thank you very much for watching the video. This is my mail ID. If any doubt is there, you can mail to me. Thank you.